visualize and analyze the associations and relationships between various entities and actors. As we like to say, once you have a hammer, everything looks like a nail. Similarly, once you have these capabilities, we can now visualize any kind of data as a network. So in this case, we're taking the airline data with the weather factors that we brought in. And here you'll see that we can now do any kind of filtering or even clustering. So in this case specifically, we are trying to cluster the different airports by the common weather factors and patterns and weighted by the delay that is caused by these unique weather patterns. So here you can identify which airports are specifically affected by strong rain or which airports are more likely to be affected by fog or sleet or freezing rain and so on. And here you'll see that it's a nice interactive and visual tool which you can play around with. But more importantly, we can fully customize this and make it look however we want. We can change everything from the size to the icons to the color and so on. We can also do some very interesting anomaly detection, which is using unsupervised learning methods to identify clear anomalies. In this case, we are trying to identify the origin airports themselves that clearly stand out with respect to these weather patterns and the delays caused by them. Interestingly, Chicago O'Hare stands out, and we know that is because it is affected by multiple extreme weathers, and it also results in numerous delays. So that's a very interesting finding. And again, there are a lot of different anomalies that we can now drill down into and identify what's going on. So that's the network analytics, where you can not only do filtering and clustering and anomaly detection, but also do scoring for predictive analytic methods using an interactive and intuitive tool. Also, the results of these various analyses can be brought into the Statistica workspace environment. Here, we can use a network analytics node and connect to the server, and this now enables users to look at the various networks that were created. So in this case, we'll choose the airport weather patterns network, and we can now select the different models that were run. So let's bring back the results of the anomaly detection and specify our actor class. So we can now look at the results of our anomaly detection model, specifically for origins and which of these were classified as anomalies. If needed, we could also select only a subset of suspicious actors. This level of integration allows users the power to use a distributed graph database for processing, thin client for an interactive UI, and the workspaces for further processing and reporting of results.